David Can here with another IB question in topic 7.1. We're looking at properties of light, so quantum properties of light. In this question we have one of the wavelengths in the absorption spectrum of helium, and it occurs at 588 nanometers. We want to show that the energy of the photon at that wavelength is 3.38 times 10 to the negative 19th joules. So we want to find the energy of a photon based on its wavelength. We may know that the energy of a photon is Planck's constant times its frequency, but we don't know the frequency of the photon, we know its wavelength. Fortunately, we also know that for any wave, the wave speed is equal to the wavelength times the frequency. What that means is that we can express the frequency in terms of the wave speed, which in this case is the speed of light, and the wavelength. That allows us to make that substitution over here and turn the equation for the energy of a photon into hc on lambda. Okay, so this we can solve. Planck's constant is in the data booklet, 6.63 times 10 to the negative 34. The speed of light is also in the data booklet, 3 times 10 to the 8th meters per second, and we'll divide all of that by the wavelength. 588 nanometers is going to be 10 to the minus 9. All right, we'll put that in our calculator, and we do get 3.38 times 10 to the negative 19 joules. Next up, we have a diagram below that represents some of the energy levels of the helium atom. So these are the different energy levels that helium's electron could have. We want to use the information in the diagram to explain how absorption at 588 nanometers could occur. So to answer this question, first we need to understand what these lines represent. These lines represent the electron shells, or the electron orbits, if you like, of helium's electron, or helium's electrons. There is sort of the ground state, and some other shells are also shown, as well as an ionized state, where the electron is freed from the atom. And we see different debts of energy at lower and lower shells. The further the electron falls in, the more energy debt it has. So then the question is, what energy transformation is taking place when this atom absorbs a photon at 588 nanometers? We have to recognize that when it absorbs that photon, its electron is absorbing 3.38 times 10 to the negative 19th joules. So is there a way for its electron to gain 3.38 times 10 to the negative 19th joules of energy? And when we look at this chart, we see that there is. If the electron is at this shell, and it moves up to that shell, then the difference, negative 2.42, take negative 5.80, is 3.38, and then we have our scale on the side, times 10 to the negative 19th joules. So the last thing that we need to do is just explain in words what we've shown in that diagram, and that's that that's that moving an electron from the shell at negative 5.8 times 10 to the negative 19th joules to the shell at negative 2.42 times 10 to the negative 19th joules is associated with a difference in energy of 3.38 times 10 to the negative 19th joules. And that's what allows it to absorb that electron.